Already we discussed in the last session about summary about this topic. So linear differential equation, which is divided into two parts mainly: differential equation with constant coefficient and differential equation with variable coefficient. For CF we have three methods there, but for PI near about eight methods we have. Out of that eight method, on method number 1 to 6 we have one 5-mark question. Then method number 7, which is variation of parameter, for that on that again 5-mark question, and variable coefficient we have a 5-mark question in the examination generally. So that about a general trend. So indirectly what I would say, instead of only the undetermined coefficient, this method is not important, undetermined coefficient. Otherwise each and every method is very important to get that 15 marks from LDE there. Okay, but that's not only the syllabus of LDE. There is a small part of ordinary differential equation, or I would say linear differential equation of first order and first degree. Linear differential equation of first order and first degree, and that is a linear differential equation that have the 2 marks weightage there. It have the 2 marks weightage. So that part we are not completed. So let me start that part. So how to get the solution for first order first degree differential equation. So the first method that we have in a syllabus is the exact differential equation. So first of all, the differential equation here, this differential equation is written as m dx plus n dy equal to 0. Actually, it can be written in a dy by dx form. Okay, so if you divide throughout by dx, it is m plus n dy by dx is a 0. Which one is a first order first degree differential equation, and that equation will be exact if dou m by dou y is equal to dou n by dou x. So we require partial derivatives. So partial of m with y should equal to the partial of n with x. Okay, and if it is an exact differential equation, we can very easily get its solution by this formula. Okay, now actually how this exact differential equation created. So let I tell you, these are just differentiating some primitive is just equation. If we take total derivative of that, we get a exact differential equation. I will write one equation here for a very simple equation. Say x square y is equal to 10. Okay, or x square y is equal to c1. Now if we differentiate this with if we take a total derivative, the meaning of total derivative, or you can say you can differentiate with respect to y and then convert in that other form also. So I'll write like this. We require here a product rule. So first into derivative of second, okay, like this, derivative of y is a dy plus derivative of a first, which is a 2x dx into y into is equal to derivative of 10 is a 0. Thus we got this equation x square dy plus 2xy dx is equal to 0, or I will say this is a m dx plus n dy equal to 0. What is the value of m? The value of m is here 2xy, and the value of n is x square. Now what is the dou m by dou y? Yes, anyone? What is the partial derivative of m with y?
2x.
Yes. And what about dou n by dou x? That is also 2x. So we observe here dou m by dou y is equal to dou n by dou x happen, and hence it is exact. And generally all these equations are exact if you obtain by total derivative. If you take a total differentiation means you are differentiating with respect to all variables there. Okay, that's a total derivative. And you will observe this one is exact. And now if you want this solution back again, but instead of particular we get a general solution actually. So how we can get? We have to integrate m dx, treating y as a constant. Okay, so I will write here integration of m. The value of m is a 2xy. The value of m is a 2xy. So integration of 2xy dx, treating y as a constant, plus integration of, now we have to take only those terms of n which are free from x, sorry, terms of n not containing x, correct. So in the end, now there is a single term x square. Generally, the terms are separated by addition and subtraction. Terms are separated by addition and subtraction. So there is a single term n is equal to x square, and that term is containing x. So there is no term. There is no term which contains x. So I'll write here 0 dy is equal to constant. That's a constant of integration. This is the formula that we have. And now what is the integration of 2xy with respect to x? Is it because it is x square by 2, but 2 gets cancelled, so I will say x square y equal to constant, and we get this as answer. And you'll observe that is the same answer here. But this only the particular solution, it is a 10 there, and here is C is a general solution there. Okay, now what you have to remember. First of all, whenever you are given first order first degree differential equation, step number one, we should check this condition. Dou m by dou y should equal to dou n by dou x. If they are equal, we say that's the exact differential equation, and using this formula, we can find a solution there. We'll come to this formula with examples again. So should remember formula, integration of m dx, treating y as a constant, and those terms of n which are free from x, that we have to take to integrate with y. Any doubt in the theory? Okay, so I'll move to the numerical here. The example is on the screen now. So this question is asked in 2018 for 2 marks. So generally these questions are very simple, so hardly they will come for 2 marks there. So we are given some differential equation which is in the form of m dx plus n dy. M into dx plus n into dy equal to 0. So write the values of m and n, check whether it is exact or not. If it is exact, find its solution. Let's do it. Yes, anyone completed? Can you tell me, is it exact first? Is it an exact differential equation? Is it an exact differential equation? Yes. No one is responding. Yes. What happened? सब सो गए? Hello. Am I audible?
Yes, sir.
Then क्या हो रहा है?
Yes, sir.
Yes, sir.
हाँ, अभी सब बात कर रहे हैं सामने. हाँ. तो क्या हो रहा है? एग्जैक्ट चेक किया नहीं किया? कैसे करते हैं? हाँ? No one is there. Yes, Ankur, what happened today? So the first thing, comparing it with mdx plus
N dy equal to 0, sir.
Correct. So we get m and n. So the value of m we get as m dx is there. So y square e raised to xy square plus 4x cube, and the value of n we get as 2xy e raised to xy square minus 3y square. So dou m, yes, dou m by dou x, is it?
No, sir, by dou y.
Dou m by dou y we have to take. Yes, so you should be careful. which derivative we require. So dou m by dou y, sorry, we want. So dou m by dou y. Yes, anyone? How to differentiate this? Obviously a product rule. First function y square into derivative of the second, e raised to xy square into derivative of xy square is a
2y,
2xy.
sir. 2xy, sorry.
Yes, correct. Plus e raised to xy square as it is, and derivative of y square is a 2y. That's fine. Derivative of 4x cube is a 0. Okay. So indirectly we are getting e raised to xy square into 2xy cube plus 2y. This is a dou m by dou y. Now dou n by dou x equal to. Now dou n by dou x equal to. Here we should use the product rule again. So 2xy as it is. Derivative of e raised to xy square is e raised to xy square into y square, because we are differentiating partially with x, plus e raised to xy square into derivative of a 2xy with respect to x, and that's a 2y. And you will observe, if you take e raised to xy square common, we get the same term. E raised to xy square, we get 2xy cube plus 2y. Hence, dou m by dou y is equal to dou n by dou x, and the equation is exact. So always you have to prove it there. Always you have to prove it there that the equation is exact, and then only you should use that formula. Don't write directly the answer, because why we can use that formula? Because the equation is exact there. So dou m by dou y is equal to dou n by dou x. We should say thus equation is exact. So right up to here. Once you finish, tell me so that I will do the integration part or that solution part. Yes, Nakul. Want to say something, Nakul?
So, sorry, sir. What happened?
No, no issue. Your mic is on. If you want, you can talk.
Sorry, sir. I couldn't submit the assignment yesterday because the internet was down due to rain.
Okay,
Like
okay.
it was raining heavily and the wind pressure was too much, so the
Yes.
power broke down near my
No,
house.
it's no issue. I already told, whenever you have some issues, you can submit it and inform me on the WhatsApp. So I will take care of your attendance. Okay, okay. I will do it now. I will mark your presenting. Don't worry. You submitted now.
Yes, sir. Submitted.
So the first part here, this is the exact. Come to the numerical mainly. Uh, Now, as it is exact differential equation, uh, we use this formula: integration m dx, treating y as a constant, plus integration terms free from x of n dy is equal to constant. This is the constant of integration. That's a formula. So let me write all the terms of m first, m dx. So this is everything, we should write it as it is. Y square e raised to xy square plus 4x cube. So this is m dx, and treat y like a constant. Plus now we write only those terms of n which are free from x. So for this n, in this n, we have, yes, terms
Sir, minus 3y square.
minus 3y square. Very good. So it is a minus 3y square. Only one term is there. So there are two terms actually. First term involves the variable x, and that's why. So now last step, we have to integrate this, treating y like a constant. So y square as it is. Integration of e raised to xy square is e raised to xy square divided by y square. And this is 4 x raised to 4 by 4. That's the integration of this term. And minus 3 y cube by 3 is the integration of that. So if we simplify everything, the final answer will be e raised to xy square plus x4 minus y cube is equal to constant. So whatever the original differential equation were given, that is actually obtained by a total derivative of this equation. If you take a total differentiation of this equation, you will get this question only, that differential equation only. So take a total differentiation of this and you will get this, and that is the differential equation. So to create a differential equation, we have to eliminate the arbitrary constant actually. So any doubt, anyone? Okay. So everyone completed? Yes. Asif already said done. Yes, very good. Very good, Asif. So someone is thinking use of the first step is only that we can use this formula. Correct, correct, Harsh. Is it Harsh? No, Hanif. Okay. Yes, Hanif, you are correct. So whatever we done on the first part, that is mainly to use this formula. If that is exact, then only we can use this formula for a solution. Okay. Yes. Okay, next question I will show you. So do this question. Do it. The differential equation. The first thing that you should observe that here only dy by dx term appeared. So that is the first order, first degree differential equation. So whenever it is a first order, first degree differential equation, it's easy. First, you should check whether it is exact first. Always you can try from exact only. So to write the values of m and n, you should convert it in the form of mdx plus ndy equal to 0. mdx plus ndy equal to 0. That form you should write. Can anyone tell me what should be the value of m? What should be the value of m here?
Sir, sin x plus x cos y plus x.
You know, mdx, na?
minus
Y cos x,
numerical.
y cos x plus sin y plus y. So don't do these mistakes. Okay. So this should be m, because this cross multiplied, then it become mdx, na? That way.
Yes, sir.
And then plus ndy. So now one more thing again. If you take on that side, it become minus actually. So you should not just cross multiply and convert the denominator to the RHS there. I think you take this term on that side, then that
Sir, it will become minus y cos
okay,
x
I think it is
minus sin y.
Is it the value of n is plus or minus? Plus, no, again, because we have to
Sir,
take on that
n will
side.
be plus, m will be minus.
Okay, let me check. Is it x cos y? Only the thing is whether we have to write down outside plus or minus there. So you take this term on RHS, minus sign is there, cross multiply, and again on plus, it should become plus, na? Both should be plus.
Yes, sir. N should be plus, sir.
Plus
sir, but
only.
why m will be minus because it will be on the RHS side, sir.
But we take on one side, na? Everything.
Yes, sir. Yes, sir. Okay,
So
sir. Then it will become plus, sir.
plus
Yes,
only,
sir.
yeah, correct.
Standard form, sir. It will become
Correct,
plus.
correct. So no need to give minus sign there. Okay, that's one thing. Now let me calculate dou m by dou y. Yes, tell me the derivative of m with y. Oh, too much time, huh? Cos x plus 1, is it?
Cos x plus
1. No, there is
Cos y
cos x
cos
plus
y, sir,
cos y is also there, correct. Cos x plus cos y plus 1. Okay.
plus 1, sir.
And dou n by dou x, derivative of sine is a cos x, cos y plus 1. Therefore, dou m by dou y is equal to dou n by dou x, and therefore equation is exact. That about the first part. First, you should show that this equation is an exact differential equation. This equation is a exact differential equation, and now you have to integrate. Okay, now we can integrate and we get that answer.
Sir, your voice lagged.
Voice lag is there. I don't know, is there a network issue or something is there? Okay, should not happen. Is everyone facing the same issue? There is a lack of voice, lag
Sir,
in.
actually, there was not a lag. The voice was not there for some time, sir.
Yes,
And
yes.
then now it is fine, sir.
Okay,
Earlier, for some time, sir, it was not there.
okay, okay. I'm probably disconnected maybe. Okay, yes, the voice was not there for about 5 seconds. Okay, okay then, sir. So I hope all you just seen that exact part. Now let me see a solution part, a second part. I'll change this ink and I will take this one. So now the formula is integration of m dx. M is y cos x plus sine y plus y. So integration m dx, treating y as a constant, plus integration of now terms free from x of n. Can you tell me which terms are there which are free from x? Yes, how many terms of n are free from x there?
Sir, zero.
No. Okay,
Sir,
zero.
zero
Very
terms.
good, very good, very good. Kaushik, yes, no terms correct. So it is a 0 dy and that equal to constant. And now only the thing that we left here is the integration. That integration there. So for integration, we'll say integration of y cos x with respect to x. Y is like a constant, so y as it is. Integration of cos x is a sin x. Integration of sin y with respect to x is x sin y. Similarly, integration of y with x is xy. And that's the answer. So this is the answer. Y sin x plus x sin y plus xy equal to constant. Any doubt, anyone?
No, sir.
No doubt. So can we move to the last question then? Last question for today. One more numerical on this exact differential equation.
Yes, sir.
Okay. Well, only two example was there, so no problem. So here we'll do one more short. There are three small types like this. First type just we discussed, which is exact. Second is a linear differential equation, and third is a reducible to linear. So that about the three types of the questions are for 2 marks there. Okay, so question can come from any of that. But if I observe last 3 to 4 years, mainly the questions are coming only on exact differential equation. Okay, last 2-3 years the questions are coming on exact there, but by chance if it is coming on linear, you should able to write it. So what is the important part in a linear differential equation? The most important part is the identification. Now, how to identify? Here, if you focus in the case 1, the differential coefficient throughout this equation, there is a function of x. Here is a function of x. So what is there? Only a dependent variable y and its differential coefficient both have the degree 1. Both have a degree 1. You will observe only y appeared. If suppose y square is there, y cube is there, okay, and dy by dx is always there, so you should not worry about it, because higher order differential equation we solved by cf plus pi method. Okay, that cf plus pi, that is a complementary function plus particular integral. That way we solve higher order differential equation. But to solve this linear first order differential equation, if there is only dy by dx and it's y, only y is present, then it's linear in y. So this differential equation is linear in the variable y. Okay, so that is a important thing. Then the equation is solved by this way. First we calculate some factor. By multiplication of that factor, the equation become exact and we get a solution, and that factor is known as the integrating factor. We denote it by if. Okay, this if is an integrating factor. Integrating factor is e raised to integration p dx. Okay, e raised to integration of p dx, that is integrating factor for dy by dx plus py equal to q, and the solution is given by this formula. The formula is y into integrating factor equal to integration of q into integrating factor dx plus c, and that becomes the solution of that differential equation. Yes, few of you may complete. Yes, Akshay is saying this one is you already learned in 12th. That's a very good. So it's just repetition then. I think exact is also there in the 12th book. Mainly the linear equations are there. Yes, true. But now you see a little different thing. We don't have that only y. Instead of only y, there is only x. If only x appears and dx by dy appear, that equation is said to be linear in x. It is a linear in the variable x. Okay, and otherwise, yes, there are function of y. There y cube, y square, sine y, cos y, log y can be there along with that. But dx by dy and x is appeared. It's a linear in x. Then integrating factor is evaluated with this formula, and solution is taken by this formula. Okay, we are not going in the detail of the method or detail of the derivation of the formulas of solution there. Just you have to remember this is the case, and in that case, to get a solution, we generally apply the linear differential equation method, and we get that required answer there. Okay, let me do one example on this linear today, and or we'll close this chapter only. Okay, because it's a 2 marks question, so I will take one question on this type and one question of reducible, and we'll stop here only. Okay, so can anyone suggest is it a linear in x, linear in y, or yes, what you are observing?
So linear in y.
If it is linear in y, it's not in a standard form. So to write in a standard form, what should be done there?
So we'll divide by 1 plus x square.
Very good. Yes, correct. Nice. So first of all, given equation can be written as dy by dx plus 2x upon 1 plus x square y is equal to cos x upon 1 plus x square. Cos x upon 1 plus x square. And now we are comparing this with the dy by dx plus py equal to q. So this gives us the values of p and q. So this gives capital P is equal to 2x upon 1 plus x square, and capital Q is equal to cos x upon 1 plus x square. Once you get PQ, yes, first step, we should calculate integrating factor. Integrating factor is e raised to integration of p dx. There is no constant of integration here. So e raised to, what's the integration of 2x upon 1 plus x square? What is the integration of this part? 2x upon 1 plus x square.
2 log 1 plus x square.
Log of 1 plus x square only, correct. Remember, 99% of the case you require this formula, integration of f dash x upon fx. See, you can observe the derivative of denominator, that 1 plus x square present in the numerator, that is a 2x. So integral of f dash x upon fx is a log fx. So this integration become that is a log of 1 plus x square, log of a denominator. But e and log are anti-function, and we left
Sir, 1 plus x square.
1 plus x square, correct. That is the integrating factor. Now, once we get integrating factor, we can write its a solution. We can write its solution by the formula. Therefore, sorry. Yes, y into integrating factor is equal to integration of q into integrating factor dx plus c. Okay. And now we have to replace these values. So therefore we say y is equal to integrating factor is 1 plus x square is equal to integration q is cos x upon 1 plus x square. Integrating factor is also 1 plus x square. So this integration becomes simple. What's the integration of cos x? What is the integration of cos x?
Sin x.
Sin x, correct. So what happens then? The final answer will become y into 1 plus x square is equal to sin x plus c. That's the answer. That is the answer.